Good night, sir.
Hey, Andrew, what's up?
Just a little stressed and tired. Want to sleep.
Uh, if I tell you what I'm doing now, you tell me that I'm lying. So press pause. I'm right where you are, Papa.
I cook though.
No, me I'm a bed lay down.
Me just don't cook early and they're eating a class.
Well, fortunate you. Fortunate you. You're understanding the McLaren's expansion?
I'm getting there. I understand it. There's some
Mhm.
calculations that might just come up that kind of throw me off a little bit, but once I review back calculus 1, right, it
Mhm.
becomes apparent on what to do. Okay.
Okay. I'm gonna post a question on. I wrote a question. I'm gonna post it so you can have it for me. So you can try that one. I mean, it is it is the same McLaren's, but this time now it's the logarithmic function. So last on Tuesday we looked at the exponential function, and I'm giving it a logarithmic function because they can't give you anything. They can't give you exponential, logarithmic. They can give you any other functions to work with. So just take your time. We still have we're within our grace period of 15 minutes. So just take your time and have your food to digest while you work on that one for me.
Okay, sir. Uh,
Good evening.
Good evening, sir.
Hey, Shaz. Hey, Rash. What are you doing? So there's a question that is posted here as example number 7.2 now. Find the Maclaurin series of the function f of x is equal to ln 8x plus 3 up to the term in x to the fifth. Try as best as possible, please. What I'm trying to do here is just to refresh your memory about the differential of the logarithmic function. What is the differential of ln x? Anybody remembers?
One over x.
1.
Evening, sir.
Good evening, sir.
Yeah. Very good. Yes, indeed. 1 over x. And good evening to the rest of you. Very nice. All right. So continue working on that for me, please. And thanks. I'm going to give you about another 5 minutes to complete this question, and then we'll go through. You notice I don't have my solution there because it was just generated a while ago. I've not yet done the solution. We'll do the solution together. All right.
Sir,
Yes, Sash.
remind me again, please. Is this function 2 terms?
No, it's a one-term function. Remember, ln, and the function is in front of ln. So it's not the product. If the 8x minus 8x plus 3 was in front of the ln, it would have been 2 terms. The 8x being one term and then the ln being another term. But when the ln is in front or to the right of, when the function is to the right of ln, that becomes part of the function. So it's just a single function you're looking at there.
Okay. All right.
You asked the question because you're wondering if you're using the product rule.
Yes, sir.
Right. No. So the only use a product rule. If I'd given you, say for example, and thanks for giving me that idea. So since if I'd given you the question, say 2x ln 8x plus 3, then that would be a product. The first term being 2x and the ln 8x plus 3 being the second term. So I'll give it that as a second one. Thanks, Sash, for that question.
Wow, okay.
Obviously, we finish it.
Not yet, sir.
Not yet, sir.
All right, cool. One word. One word.
Lord, help me in this journey.
Say that again, Sash.
I need the Lord to help me in this journey.
What did you get for your first differential?
Sir, 1/8x plus 3 times 8.
Yeah, so the final answer is supposed to be 8/8x plus 3 down.
Yes, sir.
All right, good. See, we start off right. What is up for the second differential? Yes, yes, no. Go ahead. I was about to say, Sash, come here, shut your throat. So go ahead,
I'm
Charles.
just not gonna say it. Make sure we talk.
Negative 64 over 8x plus 3 all squared.
Good job. And what do you get for the third differential?
It sounds like me going to part with Charlene. I go.
All right, there's some. All right, there's some stopping us, sir.
It can't stop this. So.
No, as in, my day still at work.
Oh, it is still at work. All right, one work, man, one work. The race is not for the swiftness, for those who can endure, and endure to the very end of it. So you go and work. Oh dear. Oh dear.
Sure, your screen looks so small.
Yeah, because right. Let me go here. I'm here trying to do when you find f of 0, what do you get?
ln 3.
And what is ln 3?
So for bringing it down more, 1.1.
Okay, all right. And then f of 0 for the other one was?
So what first?
Well, yeah, we have, sir.
8/3.
I was doing, all right, I was doing the question and then I don't know where I'm at. Sorry, let me not say I don't know where I'm at. That's why I don't like doing these questions too. To project because it
look like all of us.
Yeah, it just you see how this one looks? Like it's all over. Oh my Lord.
You can get my understanding, sir, because from the beginning you've been doing it like that. So it,
yeah, it I have to go find a nice way of doing it. Because here no. All right, so for me, I was working the question, like as like you were working it, and then I stopped and so you agree with this for the second differential?
Yes, sir.
Yes, sir.
All right. Okay. Okay. Let me just quickly write on my third differential for you. 64 times 8 times 2. You get 1024 negative.
Yes, sir. Yes, sir.
And all of that is over to the third power.
so you just said negative or whatever?
Sir, it's not negative.
They're not negative, positive.
Oh yeah, because it is negative 64. Yeah, you're correct, man. You're correct. You are correct. Up here says negative, this is positive, yeah. You see, you soon get good teaching. You just and say, oh, no, sir, you need an error. So f of 0 is going to be
Turn F triple
10,
dash
24 over
to the-
27.
and
Yes,
F
sir.
triple dash to the right, this is sir. You see, I have F double.
Say it
double
again,
dash.
triple dash. Yeah, thanks again.
Right.
Thanks here. Well, even another class, you know. Already, you know. Give me trouble.
Be a correction, I guess.
We say, no, but feel nice,
Sir,
man. I don't know why.
Sir, you know, me I wonder, no, sir. Come here, look at me and say, wait.
No, man, I feel nice, man, because sir, teacher and students, I understand. Whoa, Ryan, away there.
Right here, boss. Right here.
No, man, we want to correct between the Ryan. Yeah. When you say, no, sir, it's triple dash. All right, so yeah, triple
One
dash.
day, one day.
All right. All right, so let me just check on this here now. I should put this in. But that's nice though. It's good, you know, you guys, I know you guys are learning, your teachers making, no, teachers making errors in computational and otherwise, and you guys are saying, nope, sir, that's not how you taught us. Fix it.
Sir. Yeah,
yeah, well, no one would know that. All right, so this is f to the 4th dash. Let me fix that before I hear say, no, sir. And it's going to be the denominator. Oh, crap, no. Hold on. Oh, God, how did I get this? You don't call me, I'm in a class, you know this. Hold on, please. So it's going to be that to be this times that. I'm happy that you guys, hey, TT, you're absent on Tuesday. And I didn't get a matrix from you, 3 to the 6. Copy. All right. All right, you look at that and tell me if teacher is, what is to the 4th? If teacher is right. 10, 24 times 24. Murder. No, why would I have to go all the way up to that? Tell me that's what you got here.
Negative, sir.
Negative, sir.
Yes, I put that there to see if you're paying attention. Right. You are correct. This is encouraging. I'm liking it. I'm liking it. I'm liking it. 24,576. And 3 to the 4 is 3 is 9. That's 81. Don't? Oh man. Whew.
You can break it down further.
You can go down further. Let me just check 24576 over 81. Yes, 8192 over 27. 8192 over 27. Alrighty then. And then I need to do it one more time. So I need to copy here. Yeah, this copy and paste going to home. Bam, 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 paste. The denominator times the differentiation of the numerator. Let me share screen so you can, for those of you who are not remembering, can actually see what is happening there on my black screen. The denominator, which is this, times the differentiation, copy, times the differentiation of the numerator, paste, times 0, minus the numerator, just minus this, don't. Minus the numerator, which is that times the differentiation of the denominator. Let me just paste it right here. So put that there. So call this 4. So call this 3. And call that 8. And put the multiplication same right here. So and 2 times 4 call that 8. So. Yeah, cute.
Stop.
Yeah, no, it's whenever you share your screen and you do a new share and you close the new share, that's what happens. And I should know, and I never did it. Bam. But cut that and I do that and I come so paste it. Whoa, 24576. 24576 times 8 times 4. Wow, no, that's too much. That's 78. That's 78, 64, 32. And that will be to the 5th power. I have 3 up here. That's going to be down to the 5th power. Copy. Paste. That's what I got. 78643 to the 5th power. I mean, over all of that to the 5th power.
Yes, sir.
Yes. Right, sir.
And that's supposed to be 5. You see, sometimes when you see my document, you see the 5th differential about 4 because I am not even doing that. So this is correct, right?
Yes, sir.
Yes, sir.
Nice. Paste. Oh, see, when I don't even tell me, says, sorry, you're supposed to have an F to the 0 right there. No, but not work with me. Ryan, here was your opportunity, you know. To say, sir, F to the 0 right there, say no.
Soon, boss, soon.
All right, that divided by 3 to the 5th, 3 raised to the 5th power. And that's going to be, well, 262144. I don't like this question.
You want to stretch out from early?
Yeah, no, but you see, the thing about it is 262144. The thing about it is, I have to give you, I don't know what the exam is going to look like. And I have to give you variations of the questions. So I cannot give you any stuff. And you see, again, no, look at what is happening now. Oh Lord.
Sir, like how much this would mark out of?
This question is about a good 10 marks. 10,
sir, 10.
I don't know, you want more than 10?
Yeah.
No, so you're too craving. 10 is good. All right, if not again, don't know. I don't like how this thing looks. It looks, if I were a student, I would say to you, sir, I'm not following. So I'm going to just do like that. F of 2 come here. So finish F of 3. And then I call this THIRD, BIFF, BREN, TIAL, woo! ERENTIAL, so third differential. I used to love doing these questions when I was going to school. I feel bright. You know, you had the one question that takes out 2 pages. No, man, when you do them enough question that take enough page, man, you're bright. 4, 5. This is the fifth differential. Bam, bam, take that there, take that there. And then now you know that you're the fifth differential. So third, you are the second differential right here. Let's see, C-O-N-D-D-I-F-F-E-R-E-N-T-I-A-L. D-I-F-F. And then we have the first F-I-R-S-T-D-I-F-F-E-R-E-N-T-I-A-L. I-N-I-T-I-A-L. Initial, my first differential. My second differential, I take out that second differential, my third differential, my fourth differential. And then, of course, you no need to turn and look like the rest of them, fifth differential. And then, alrighty, wow. Okay, so you guys are all with me in terms of how it is that I would have ended up with my differentials, all right? And will also agree with me that you know how to get the f of zeros for all of those. True, false, indifferent?
Yes, sir.
All right. Now, so this is just one part of the calculation. One part of the calculation where you are going to be required find the Maclaurin series of the function f of x equals to all of this up to determine x to the fifth. It means that I have to do the up to the fifth differential. So this here gives you how far up I should go. Now this is the initial one where I use a function, substitute 0 into the function to get my answer here. So everybody's supposed to can get this 1 mark. Then I'm finding my first differential, differentiating the function, differential of ln x is 1 over x. That's the only time I'm going to have ln in my function. And then, matter of fact, let me just do something here so that you can, I heard somebody say it, so let me just do it. ln 3 and it's equals to 1.0999. Sure, we did just write 1.1, am I right? Yeah, man. And we just, as I said before, I'm not constructing the question yet to tell you exactly what it is that I expect you to do and how the question will be worded and the whole stuff. My aim for this exercise is to get you to do the question, to understand what is to be done. And there's a particular reason I didn't do the question beforehand, because I want you to see when I was working. I want to go through the question with you, as opposed to just having the question and then presenting the answers as I normally do. There are times it's very useful because I save on time doing something like that. But in this other case, no, I really want you to see exactly what is happening. So having calculated my second differential, my first differential, you know what I can do now? Now I can actually not seep out any of the lines if I'm going to be like this. So my first differential is going to be just simply differential of ln x is 1 over x times x, and it's going to give me 8 over 8x plus 3. F of 0 of that is going to be 8/3, second differential, so forth and so on. Get my answer right here. My third differential, all my answers in blue are what it is that I'm going to be substituting into my formula. Of course, your teacher is very good at this, right? Copying and pasting. This is my formula. Working smarter, not harder. I'm not lazy. So this is my formula that I'm going to be using, right? And in this particular case, let me just do a little amend right here. F of 3, copy plus paste. This is when it become F of 4. F of 4. I don't want anybody to be left behind. So at least when I'm doing this stuff, you can see why I'm doing what I'm doing. F4, x to the fourth, then copy plus is plus x to the fifth. All right. So in this case here, oh, finally, he decided to come on. Oh my Lord. All right. So what is happening here is I'm going up to the fifth. So I have my expansion here, f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, right? Plus dot, dot, dot. I'm going to stop here. I am doing this again. I know I've done it before, but I'm doing this to help somebody who may not have seen this or would have seen it, but is not understanding or need a little bit more prodding. If you notice, this over here says 0 factorial over 1 factorial over 2 factorial, 3 factorial, 4 factorial, 5 factorial. But I don't have to put 0 factorial because 0 factorial is 1, so is 1 factorial. 0 factorial is equals to 1 factorial. All right. All I'm going to be required to do now, all of these thingy bobs that are in blue, I'm going to substitute. This is 1.099. 1.099. And that's how I'm going to get my series. That's all I'm doing, guys. The majority of the work was already done. All I'm going to be doing now is just substituting into my Maclaren's expansion, write it down to its lowest term, and get the stuff. Then some never know, could I get decimal? And can I get them big numbers here? Absolutely. Absolutely. Right? They may not give you a question like this. I just wrote a question out of the top of my head because I want you to understand what is happening. Sashi gave me an idea. I'm going to work a question like what Sashi gave. And we just want to play around with it. Incidentally, I have 3 things planned for tonight, and I must get through those 3 things. One is to do some more Maclaren's. I must go through some asymptotic graphs with you, and I must go into some small changes with you. Even 2 questions on each. Those other areas are pretty easy. The asymptotic graphs are easy. You know how to do those already. I guarantee you, me teach you calculus 1, me know how to do this. That's not going to take me more than 10 minutes to do. I promise you. And the small changes, it's again on differentiation because we're looking at applications of differentiation. It's on differentiation. It's really not difficult. You plug it into a little formula and you should be fine, right? This of the 3 is one of the big boys. So that's why I'm spending a little more time on it. But I'm sorry, tonight I have 3 objectives that I must cover. What time is it? 8 o'clock. I must cover. By 8:30, I'm going to end here. You don't have to worry. I will come back to class at the start of class again and give you a little 1 question on Newton-Raphson, and give you 1 question on Maclaren's, and give you 1 question on whatever it is to keep your mind going. But I must go through those 3 areas that I have planned for tonight. One of the areas would have been what I had planned for you on Tuesday, but time was against me, so I didn't type those questions. So between Tuesday and now, I went ahead and typed the questions. So I have, oh crap, I needed to do the graphs. Oh man. All right, anyhow, you guys have this more so you can do the graph. All right, so I have done that one. Let us do now our first differential is 8/3. All I'm doing is going here and I'm going to substitute my 8/3. Then, sir, you will put 1 as decimal. I know you're going to put this as 8/3. Yeah, we can figure out how we're going to do this stuff the other time. Right about now, I just want to put in my information as it is here. Then I can fix it up into another line. So let me put my information here. So me, I tell the teacher, so I know me I do. So even if this line here is incorrect, I can only penalize it for this line, but I'll have to give it a mark right here. because I know that you know what it is that you're doing. All right, it's very important. I don't want anybody to be missing any of my steps. These questions are long and they carry a whole lot of marks. And as a result of that, I don't want anybody to go and make any careless mistakes with them. All right, f double dash of 0, f double dash of 0 is negative 64 over 9, negative 64 over 9. But sir, how this pattern work out now, sir? You have 1 plus 1 plus 1 plus and then 1 minus. Oh no, sorry. Oopsie daisy. I'm sorry. Yes, sir. I'm seeing here a plus, then a plus, and then a minus. Sir, I thought you said that it's going to be a plus and a minus and a plus and a minus. I didn't say that. You can have everything in plus, 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 as we saw in the one that we did with the e to the x. Plus, 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 plus. Or you can have them alternate. Okay, sir. Thanks for the clarification. Please, I don't want anybody to go think says it's going to be plus minus and then they guessing the stuff and putting the things in it. Don't want you to do that. So that was our f of 2. And you notice I put 9 times 2 factorial. I'm not ready to evaluate it yet. I'm putting my answers in there raw. My f of 3 is going to be 1024 over 27. Ah, 1024. See there, 1024 over 27. And of course, it's being multiplied by 3 factorial. And then this is going to be negative 8192. You 92 over 27, don't? 8192 over 27.
Negative.
Thank you. Answer negative 8192 over. Right. Right. So it's what we have now. I have plus, plus, minus, plus, minus, plus. 2, 6. Oh, can't even call that. 262, 144 over 81. X to the 5th. All right. Everybody agree with that so far?
I'm confused
Yes,
how
sir.
you put it in this case here with the 27 times the 3 factorial. Instead of the fraction over the 3 factorial.
Same difference.
Okay.
Same difference.
I guess because it's a denominator, why you just multiply the denominator by the factorial. I bought them already denominators and so.
Mm-hmm. Mm-hmm. Thanks for the question, Sash. I'm just going to do it like this. I'm going to do, come on. You know, this thing sometimes I want to work with me, you know. And Let me just highlight this term so that you can see it. Let me highlight. I want a pretty color. All right. Let me highlight this term. Press pause and come back to you. Yes, Rashim, you are correct. No, Sash, remember the 2 factorial is in the denominator. Talk truth.
Yes, sir.
Teacher, it is still in the denominator. So I can pull out from my formulation here. Where is that? I can pull out. So this here is in the denominator. All right, let me just do this and come back here. So because I want you guys to develop mathematically. So the 2 factorial is in the denominator. Control save. The 2 factorial is in the denominator. I'm not changing the position of my 2 factorial. See here, it is still in the denominator. My 3 factorial is still in the denominator. I'm not changing, it is still in the denominator. So forth and so on. But this f double dash of 0 is 64/9, negative 64/9. Second differential, negative 64/9. So it's negative 64/9. So instead of writing negative 64/9 divided by 2 factorial, I can say negative 64/9 times 1/2, because dividing this by 2 is the same thing as multiplying by 1/2 factorial. Can you agree with that?
Yeah, yes, sir.
Yep.
Right. So that's why I wrote it like this in the first place. So I'll leave it like that just to show you. All right. And 2 factorial is 2. So that now becomes 2 9s are 18. 3 factorial is 6. So 27 times 6 is going to be enough. I think like 162. 4 factorial is 24. So 27 times 24 is 648. And 5 factorial is 120 multiplied by 81. And I'm getting 927. I'm getting 9720. 9720. Let me just put that there. Look and tell me if you agree or disagree. I'm just showing an easy way of it. Yes, honey.
Sir, the minus with the 3 dots, please.
Oh, yeah. So this one will be a minus sign right here. Yeah. And so with this one. Right. All right. And then now, so what I've done, I'm doing it in stages, and I'm going to leave this like as it is, as I have it here, because I want you to see it. So I'm just working on my denominator first. Then what I'm going to be doing now is, trying to evaluate what is 64. Can I break down 64 over 18 into anything simpler? Like 32 over 9. And my 1024 into 600 into 162 can go as 512 over 81. 512 over, and I'm going to need the answer like this: 512 over 81. And then my 8192 over 648 is going to be 1024 over 81. 1024 over 81. And my 262 144 over 9720. Oh, it can't go down any further like so. So we need that as that. So that will be my expansion in the stuff. Now, what is the question answer to leave it to 2 decimal places? Leave your answer in 2 decimal places. Then it can go 1.10. Then evaluate what 8 over 3 is to 2 decimal places. Then evaluate 32 over 9 to 2 decimal places, so forth and so on. Remember, as I said before, my question is just to find the Maclaurin series of the function. I'm not giving you no gravy. no salad, no juice with it. We just cook the raw food. My aim here is to get you to recognize that they can ask you to do Maclaurin's with a logarithmic function. The nicer part will come thereafter. Matter of fact, I can extend this question, right? But my aim just now is for you to get the Maclaurin's up and out. Are you understanding what I'm saying?
Yeah.
Yep.
Okay. All right. So let's go. I'm going to give you another question. Are there any questions for me thus far? And I want you, since I don't have any answer here, I just want you to be purposeful in I'm giving an easier one. Let me not go all the way up to that and say go up to the fourth. And the reason you may say, so when I go up to the third, no, I want to see you be able to do multiple differentiation. I don't know. They may not carry all the way to x to the fifth, you know, but I better when sir carry all the way up to x to the fifth, so you get the practice of doing that. I make the man them stop at x to the third or x to the fourth. All right. So this one here now says find the Maclaurin series for the function f of x is equal to 2x ln 5x. What is that one now?
Product, sir.
I'm going to give you 10 minutes. I'm going to give you 7 minutes. I don't have to begin with the question yet. I want to work the question through with you. Okay, so I'm just going through okay. All right, so I acknowledge the messages, direct and other messages in the chat. All right, guys. I want you to try this one for me. Remember, the product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. Remember, when you differentiate an ln function, you get 1 over x. 1 over the function, that is. When you differentiate ln x, you get 1 over x. If you differentiate in ln whatever, you get 1 over the differential of the function. 1 over the function times the differential of it. So 7 minutes.
So run back that again.
The first
Run back that.
times the differentiation of the second plus the
First and
second
second
times the
plus
differentiation of the
second
first.
times the
So you
first.
have a product, you're differentiating a product. In the differentiation, we give you 2 things to multiply, to differentiate.
And then where this about ln again or ln x?
The differential of ln x is always 1 over x, 1 over the function. Let me put it like that.
So
Times the
1 over
differential of the function. So it's 1 over the function times the differential of the function.
dif of function. And
1
then
over the
differential
function.
of ln alone is what again?
No, man, you know, we have ln alone. We have ln with a function. So the differential of ln x is going to be 1 over x.
Okay.
But in general, the differential of an ln function is going to be 1 over the function times the differentiation of the function.
Okay. All right. Thanks.
Mm-hmm. Yes, I am.
I'm confused.
So nobody not going to say anything to me yet?
Sir, the question here, it's undefined, sir.
So how long are you going to take to tell me?
Sir, that's why I'm telling you I'm confused because I don't know what I'm going.
But nobody never said anything to me.
Nobody
And nobody don't say anything. That's why I'm here saying to myself, I don't understand why nobody is saying anything. No, tell me why that question is undefined again. So we want. Because ain't hearing anybody.
Because
LNG.
the ln of 0 is undefined. It gives an error on the
Right. But it took you about 10 minutes to tell me that. All right.
Tell me that give other people them a chance because I didn't go further than f of
The first
0.
one. Right. Very good. It can't go anything beyond f of 0.
Because I
So yeah,
realize that it's going to keep reoccurring because you're doing a multiplication.
absolutely. So it makes a difference now when I do something like that. So go now for me, please. That was done to see how well you guys are remembering what it is that we're doing. So please. All right, go now for me. It's 8:36. I'm giving you 10 minutes. By 8:45, I'm going to stop you. Start for me, please. Or continue. Finish. 849 finish.
No, sir.
All right, continue.
Sir, can I check the chat, please?
We'll do just that. Boy, why? All right. Okay, guys, let us.
For real though, sir. For real.
All right, never mind. We're soon finished. We're soon finished. I guess. All right. All right. All right. Let's go. All right, story. This too shall pass. After this course, no more math. No more math. This is the final math course. Wow. All right, let me just copy that. Copy this. Paste it right here. And my f of 0, I'm going to paste right here. My f of 0 is, what is my f of 0 equals to?
0, sir.
Very good. F of 0 is equals to 0. Very nice. F of 0 equals 0. All right, let's go to the first differential. It's a product. So it's going to be it's going to be the first case. It's going to be the first times the differentiation of the second. Differentiation of the second is going to be 1 over 5x plus 1 time plus the second plus the second is and then 5x plus 1 times the differentiation of the first times differentiation versus 2, so times 2 that copy from so it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. All of that is going to be 2x over x plus 1 times 2 and then 2x plus 1. Right? And copy is f dash of 0. Anywhere in f of x, I see x I put 0. All of that goes to 0. So, ooh, what is ln1?
Zero, sir.
Right, 0. So I'm getting 0 for the first one and I'm getting 0 for the second one also. Very good.
Sir,
Yes,
sir,
yes.
that second differentiation finish.
No, it's the first differentiation I did.
Sorry, that first differentiation finish.
This one up here, so I carry it down right here, saying I carry it down to here.
Yeah, me know, sir, that you do me ask if it finish.
Yeah,
You sure, sir?
I think so.
You sure, sure, sir?
The first times the differentiation of the second plus the second times the differentiation
Sir,
of the first.
but your second I don't differentiate.
Yes,
Isn't it
sir.
two?
Sir, where's your 5?
Sir, your second
First of
I
all,
don't
5
differentiate,
missing.
sir.
Oh, to Rockstone, yes, to Rockstone. What is wrong? Asashino, hold on.
Sir, you're tired tonight, sir.
No, very well, very much so. The
Terrible, because
first
we need that early thing that tonight.
times the differentiation of the second times my 5. And you see, any diplomatic, you see? Jesus, she diplomatic bad. Anyway, it won't change your answer still though. 5 times. But
No
yes,
matter, but you're gonna take off marks if me not have it.
dark truth. Dark truth. So yeah. And this is not supposed to be 10x. Talk truth, Yan. All right, good. Then no differentiating this. All right. I know I can understand now why I say what you said, Sash. So it's gonna be the first times well. In this question here, no, you recognize that you're gonna have a chain, but in this chain, you'll have a quotient and a product. Can you agree with that?
Yes, sir.
So let us differentiate this first part here. Copy, paste the denominator. Copy the denominator times the differentiation of the numerator. Differentiation of the numerator is going to be 10 minus the numerator minus 10x times the differentiation of the denominator, which is 5. All over the denominator squares, which is that. And then differentiating that. The first times the derivative of the second. The first times the derivative of the second. first times the derivative of the second. Hey, man, see, it's not for differentiation. I can't remember now what I talk about. First time derivative of the second plus the second plus what's the second again? And then 5x plus 1 times the derivative of the first. Look at what I did here. So I differentiated first. Look at my second differential. It's a denominator, bam. Times the differentiation of the numerator, differentiating the numerator, I'm going to get 10. Minus the numerator is going to be 10x. Times the differentiation of the denominator is going to be 5 over the denominator squares. Look at how I did this one. The first, which is this, times the differentiation of the second, which is going to be 1 over 5x plus 1 times 5. Plus the second, which is this, times the differentiation of the first, which is just 0. So I just put 0 right there. Is that okay?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yeah, look.
Make sure, because I mean, oh, this is supposed to be the second derivative. Copy. Paste. Oh no, come on, don't make this to me. Copy. Paste. And then now 5 times 2 is 10. And this is going to be 10 times 5 is 10 times 5 is 50, don't 50x. 10 times 5 is 50x minus 10. 50x minus 10. Let me just check it on. This is 50x plus 10, sorry. I don't know what is wrong with me tonight. So that's 50x plus 10 minus 50x. So it's going to have 10 over that. So copy. So that's going to give me it's just going to give me 10 plus all of that. How do I add these two? The LCM is copy them.
Oh, sorry, so you couldn't have cancelled off that 5x plus 1?
5x plus 1 where? This one here?
No, the before you turn it into 50x plus 10 minus 50x up top.
Up here? Up here? Right here, this one? No, I'm unable to do that because this is being multiplied by 10.
5x.
Yeah, I can't do.
You can.
Cancel aside a multiplication sign. If this were just 10x times 5x plus 1, I could have canceled it. But I have a 10x minus 5 right here, so I'm unable to do it like that. I'm unable to. So I'll have to distribute and then work out. So I'm going to get 10 that is 50 plus that. 10 times 5 is 50. Those 50s cancel. So I'm going to have 10 over that. Then now I'm going to find the LCM, which is going to be 5x plus 1 all squares.
Sir, please make it more example out of it, please.
You don't want to what?
No, you got the idea from me. So I say, please don't take it.
Oh, no. The point is, I don't know what CCCJ is when they send honey bunches. But the point is, in giving you the question is that you can get something that is a product. I don't think they will give you a question like this. But we are going to finish this question, but I don't think they're going to give you a question like this. On the exam condition, no. But I only did this question because I want to show you that you can get a product. But none of you should be screaming about this, because I know you guys know how to differentiate. Me not ask you. Me tell you something no how to differentiate. I know you know. The function don't look good, but yes, I know you know how to differentiate. Where was I? What's the LCM? It's going to be 5x So it's going to be 5x squared. After that, it's going to be 5x plus 10 times 5x plus 1. Oh crap, sorry. Plus 10 times 5x plus 1. Look at that. So what I'm doing here now is I do this, I'm going to get, let me get a question like this, I should have got 20 marker. So I'm adding these two together. The LCM is going to be 5x plus 1 all squares. 5x plus 1 all squares into 5x plus 1 all squares goes 1 times 10 is this 10. 5x plus 1 into 5x plus 1 squares goes 5x plus 1 times 10 is 10 times 5x plus 1. And then that now into this is going to give me 50x plus 10, 50x plus 10, and then I'm going to end up with I'm going to end up with 50x plus 20. And that's just going to be my f double dash. And f double dash of 0 is going to be just equals to 20. So let us walk through this again. So it's the denominator here, bam, times the differentiation of the numerator. When I differentiate the numerator, I'm going to get 10 minus the numerator, which is going to be minus 10x, times the differentiation of the denominator, which is 5, all over the denominator squares, 5x plus 1 all squares. When I differentiate this one, this is a chain rule. Using a chain rule, all right? But the chain rule contains a quotient and a product. Q-U-O-T-R-E-N-T and E-R-O-D-U-C-T, I think, right? So are you following what I'm saying right here?
Yes, sir.
Yeah, man. So it's a chain rule which contains a quotient and a product. So I've just done the quotient, I'm doing a product now. The product is the first times the differentiation of the second. First times the differentiation of the second, when I differentiate ln x, I'm going to get 1 over x times the differential of the inside here, which is what I left off at first, plus the second, which is ln that times the differential of that. The spirit is saying to me to put it there so that 5x plus 1. When you guys are doing it, nobody's going to say it to me, sir, how did you just get 0 there? So, right? So times it plus the second times the differentiation of first. Now, all of this piece is going to go to 0. So I'm just going to be left with 5 times 2 is 10. So it's 10 over 5x plus 1, which is this. And all of this that I distribute, 10 times 5x is 50x, and 10 times 1 is 10. And 5 times negative 10 is negative 50. This, I don't know where this answer is going now. As I said, I just made up the question, right? And this is going to be negative 50x times, plus 50x, which cancels out. Let me just do that for you to show you that it cancels out. All right, so those two cancel out. And then I'm just going to be left with 10 here. So now I'm putting everything as a common denominator. Remember, when you're doing the quotient rule, you can't do the quotient rule with 2 different pieces like that. Well, yes, you could, because you could differentiate this as it is in terms of a chain where you have 2 quotients, right? But I can put them together to get one numerator, one denominator, and then just do the differentiation like that. If you do it as 2 quotients, it's going to be very long or longer. So I'm finding the LCM, which is going to be 5x plus 1 all squares, the big of the 2. This into this goes 1 times 10 is 10. This into this goes 5x plus 1 times 10 is 5x plus 1. And if you want to check to see if you're right, this positive sign is this positive sign here. Watch me. 10 over 5x plus 1 squares here. 10 over 5x plus 1 squares. And then you can have 10 over 5x plus 1. You can have 10 5x plus 1 over 5x plus 1 squares. But that one cancels in, this one leaves 10 over 5x plus 1, which is exactly what we have here. So you know that this line is correct. And when you say 10 times 5x, you can get 50x, which is this, and 10 times 1 is 10. That 10 plus is 10 gives me 20, so that I have this here now. And f double dash of 0, that goes to 0, so I have 20. That goes to 0, so I have 1 squares, and 1 squares is 1. 20 over 1 is going to be 20. So I have 20. And then now it is that I'm going to be required to do the differential of this piece here. And you know, I'm differentiating this piece here. It's going to be the, by the way, did anybody get up to this point here?
Yes, sir.
Sir, I got the 20, but my differentiation was wrong.
Was off. Okay, no problem. No problem. All right. As I said before, we are here learning, so it's not a problem. But as I said before, I don't ever give you something like this, but who to tell it? If they do, hooray, you know what to do. So it's going to be the denominator. So let me just do this one quickly here. The denominator, copy. The denominator is times the differentiation of the numerator. Now the numerator is going to be a chain times the differentiation of the numerator, which is really 50, minus the numerator times the differentiation of the denominator, which is going to be 2 times 5x plus 1. Times 5 all over the denominator squares. So let us just double check what we have. The denominator, BAM, which is this, times the differentiation of the numerator. When I differentiate the numerator, I'm going to get 50, minus the numerator, which is 50x plus 20, times the differentiation of the denominator, which is the power rule, so it's going to be 2 times 5x plus 1 to the first, times the differentiation of the inside, which is 5, over the denominator squares, which is 5x plus 1 all squares. 5x plus 1 squares, square, which is 5x plus 1 to the fourth. So that now, and check with me in case I'm, oh, this is supposed to be the third differential, f triple dash. Ryan, wake up. So.
Why don't you?
Okay, nice. Jermaine, wake up. Matter of fact, I have not checked my participants list to see who they are. Okay. Kerika, we're not giving you trouble tonight.
Sir, after where was the 5 earlier? That's the only trouble I can give tonight.
So what?
I asked you where the 5 was in your differentiation earlier.
Oh, that's the only trouble you didn't give me. All right, no problem.
Yes.
Alton, I need to hear from you. All right, never mind. So when I multiply that by that, I'm going to get 50. 5 times 2 is 10. I'm so happy that you guys did all this level of differentiation in Calculus 1. And does this look familiar from Calculus 1?
For Calculus, I've never seen us do
Yes, sir.
Yes,
chain.
man.
Chain and quotient too.
No, man. I would have given you questions like this in Calculus. Matter of fact, I have some end of unit questions here that I wanted to give. Look on the end of unit question here. Yeah, man. You get questions like this in a Calculus 1. See your Sash? X plus 2 over x plus 1 all squares. These are some questions that I wanted to give you as just a little thingy bob, whatever the situation is. So these questions are where am I? Yeah, these questions are questions that we normally do in class. So 12 times 2 is 10, bam, 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 and then now in order to do this, now we normally look and factor out them something here. So we can factor out, we just going to factor out the 5x plus 1. We'll factor out the 5x. I think I can stop at f of 3. 5x plus 1. So copy that one, paste that, and factor out the 5x plus 1. Put that there, so comes so. Put that in one square bracket, so. All right, no. Go. Krishna, I'm not hearing from you.
I'm here, sir. I'm paying attention.
Okay, thank you, sir.
Sir, that question you know no pattern.
No, absolutely. And that's what I was saying to you earlier on, that some of the questions you can't see no pattern in it. And this is one definitely no pattern at all. All right. No, this is supposed to be to the first one now. Because that's when this is working on something going like this. So so I factor out the 5x plus 1 right here. So it's going to be 50 times 5x plus 1, yeah. Minus 10 times 50x, yeah. And then now copy. Whoa. And then all of this cancel out. I'm just left with the third power. 5 times 5 is 25, so that is only 250. 250x plus 50 plus, oh crap, guess what? 500x plus 200. All right, I need to just double check something right here because I typed into the function and I don't remember exactly what was there. So let me just see this and look at it again. Forgive me. 50 times 5x is 250x, yes. 50 times 1 is 50, see? So that's supposed to be 50. 10 times 50 is 500x minus 500x, and it's supposed to be minus 20, minus 200. All right, got you. And that's minus 200 over, that goes to the third. 250 minus 500 is minus 250. So that's going to be minus 250 and minus 150. Anybody got that? Minus 250x minus 150. The only pattern I'm picking up, Yannick, based on what we did, was 5x plus 1 to the to the first, then 5x plus 1 to the second, then 5x plus 1 to the third. That's the only pattern that I can see. And there's a 50x plus 20. And this is a no. So I'm seeing all of that there. Are you with me so far?
Okay, now.
Can you scroll up a little, please?
Scroll up.
Yeah. A little further, please. Oh, yeah.
I definitely can't end the class with this question. I have to give you something sweet to help you digest, lest none of you turn up to class on Tuesday. I can move now from here.
Yes, sir.
I'm going to do that here. So, all right. So this one is going to be pretty easy because the first two, I want up to x to the fourth. This is 0, 0. So this term is 20. And then we need to evaluate what this is. that is going to be negative 150. Anybody got negative 150?
Yes, sir.
Nice. So that is negative 150. So we have two terms, and then we have a final one to look at. The denominator. Oh, the denominator times the differentiation of the numerator. When I differentiate the numerator, I'm going to get negative 250. Negative 250, the denominator times the differentiation of the numerator minus the numerator minus all of this ugly looking thing times now the differentiation of the denominator, which is going to be 3 times 5x plus 1 to the second power. That's not where it's supposed to go. To the second power times the differential of the inside there, which is going to be 5. All over the denominator squares, 3 times 2 is 6. All right, so this is what I have. The denominator, this is right here, times the differentiation of the numerator, which is negative 250, which is right here, minus the numerator minus all of this, which is here, times, let me got my multiplication sign, times the differentiation of the numerator, times the differentiation of the denominator, which is 3 times 5x plus 1 to the third power, the second power. I'm differentiating. So it's to the second power times 5. All over the denominator squared, which is 5x plus 1 cubed. And then I just need to fix up this. This fixing up should be easier than. Did I differentiate a while ago? Yes. So I this differential, or this differential was easier than this one because I had 2 functions of it. So the function gets easier to differentiate actually. So copy, paste, no, paste. So this is going to be negative 250 in here. Take off that. Minus 15. 3 times 7 is 15 down. Minus 15. And then what is common? 5x plus 1 squares is common. So I'm gonna take out the 5x plus 1 squares. 250. 15 can go into 250? No. So what 5 can do? So this is going to be 5x plus 1 squares. I'm taking up the smaller of the 2 when I'm doing this sort of stuff. And I really hope you guys are following me now. And then I'm going to take off 5. 5 into 15 equals 3 times. And 5 into 2 equals negative 50 times. I'm going to put my 5 outside here. So, so let me show you what I did. Between negative 250 and 15, I'm taking out the 5, which is this 5 here. If I want, I could have taken negative 5, but I'll leave it as it is. And then I'm taking out the 5x plus 1 all squares. So that means it's supposed to be just one of it. So I'm going to have 50 that is left because this times this gives me 250. And 5x plus 1 squares times 5x plus 1 gives me 5x plus 1 cubed. 5 times negative 3 gives me negative 15. And this negative 250x minus 150 is here. And this 5x plus 1 squares is what I would have factored out here. So in that line, I'm now able to cancel the 5x plus 1 squares into 2 of that. And then I'm going to go left with 4. 4, 5, 6, yes. So I'm going to look at that. So there's no 50 differential, so you just take off that.
Sir, remember it's not triple dash, it's to the fourth.
Thank you, sir. Thank you, thank you, thank you, thank you, thank you. Thank you, Papa, thank you. What can I do without you guys? Well, like how COVID now keep again, now we can go name 2 food on a Port Royal.
Sir, that doesn't want to go.
Say it again.
That's not where I want to go. Remember your link from last semester?
Talk truth, yeah, talk truth. Yeah, man, I forgot to say we can activate the link, man, so we can see if we can. I hope the link still airy, so we can just go wash off some of them calculus 2 here to the 4th. To the 4th. Thanks again for telling me. That's to the 3rd, to the 4th, to the 4th, to the 4th. All right, so let's just do this quickly now. So this cancels out, leaving that. This cancels off, leaving at 4. And then I am going to 5 times, negative 50 times. All right, let me do this so that I don't skip a step. Negative 50 times 5 is negative 250. And that's x. And 50 times negative 1 is going to be negative 50 minus 50. All right. And then minus 3 times minus 250 is positive 750 plus 750 plus 450. No, yeah, 150 times 3 is 450 plus 450. All right, so let us double check that line. See, don't work out today about the question. After all, you know, the first 2 was hard to differentiate. Yeah, 5 times 50 is going to be 250 negative 250x minus 50. 3 times 250, yeah, negative 3 times negative 250 is positive 750. And it's negative 3 times a negative 150 is negative positive.
You leave off the x, sir.
Yes. Thank you, hon. It gives 150x times. And then I'm going to do this now to give me negative 250 plus 750 is going to be positive 500 x. And then plus 400. Oh, rockstone. I don't have to do that. Yeah, plus 400. So I'm going to have negative 50 plus 450 is positive 400. And negative 250x plus 750x is going to be positive 500x, which is right here. I don't have to distribute this 5 into this. Well, we have to be careful. Let me just ask the question first to see if you guys are seeing it. What is f of 0? What is f of f to the 4th of 0 right here?
Sir, the 2000 over.
No, man, 2000.
2000 flat, right?
Very good. Nice job. That's why you are calculus 2 students. So it's going to be 2000. And then that will be it, because it says up to x to the 4th. And we're just substituting. Now remember, f of 0 is 0. F first differential is also 0. It's only the second differential that will get 20. The second differential is the one with the x squares. All right, copy is the second differential is the one with the x squares, and that's 20. Everything else is 0. I can just take it out. And then the fourth differential is 2000 x to the 4th factorial. And the third differential.
So, sir, if I chose not to factor out the 5 in the fourth differential, would I lose marks for that?
No. Because remember for this, no, you know, it's just this piece that is in blue that you're really interested in, which is what I'm saying to you. The truth is, chances are I would have seen your error with your 20. I would have just kissed my teeth. If you see what I'm saying, because you still end up with the 20. You follow what I'm saying? No,
Yes,
you don't
sir.
follow? Yeah, man. And then what was that?
Yes, sir.
That was negative 150. So this is going to be negative. It's going to be 150 over 3 factorial. And then that will be that for that piece. And question works out nicely. It was a little rough in the first part. Comes out nicely. 2 factorial is 2, so that gives us 10x squared. And 3 factorial is 6. 150 divided by 6 is going to be 25. So that's 25. 4 factorial is 24. So 2000 divided by 24 is going to be equal to, wow, why did you have to come out to like that one? 250 over 3. And that's a very final answer. Question worked out pretty nicely for me, if you ask me. Pretty nicely.
Sure.
I mean, the working. Say it again, hon.
Don't have any minus in this.
Yeah, man, there's a -1. We got a -150. Didn't we?
Oh.
Yeah, man, we got a -150 there. All right, so that's what that one looks like. Yes, it's rough, but you know what I'm happy about is that we're able to go through the whole question. Remember, Excel is required.
That, sir.
Say it again, Nixon.
May I say about 30 marks for that workout, sir?
No, if I give you a question like this, if I put a question like this on the exam paper, it will be a full 20 marks. It's a full question that I'll give it for. A full 20 mark question. Remember, the question comes to 20 marks now, right? So which is the point I'm getting at. Excel is required to submit examination papers, I mean questions, items. I definitely would not submit a question like that, but guess what? You may have another community college that may submit a question like that, and that question is selected. So what I'm happy about is that I was able to come up with a question like this, just off the top of my head, come up with a question like this, and give to you. Yes, the question is rough, but guess what? As I said before, and I'm not bluffing, I know you know how to differentiate. Me not ask you. Me know how to differentiate. Some of you are doubting yourselves, but for the most part, I mean, I would say at a 90%, the class can differentiate. At a 90%, the class can differentiate, right? Give God thanks for the extended semester, because I know I spent most of my time working with you guys on the differentiation, because I knew you needed to get your differentiation here. When I come to integration, I'll speak about integration, right? But I know you guys know how to differentiate. So they may give a question like this, and I wouldn't have any control over it, because if I complain and say, but Mr. Shand, did the students do Calculus 1? Yeah. Differentiation is on the syllabus. Matter of fact, if you look at your outline, you'll see that differentiation again appears on it. I decided that I'm not going to go through all of that again, but I will give you questions so we can refresh our memories on differentiation. Every one of you in the class, including Tiana and Rashim, who joined us, they did differentiation and integration in their previous calculus course. courses. All right. So yeah, so the question worked out pretty nicely in the final analysis. I just gonna say one more thing and then I just top off the class with something a little nicer. Something that I know you know how to do already. One application, you know, sometimes you go into an organization to work that you have to build it from scratch. There may be a unit in that organization that you are the first manager and or first supervisor, and you have to build it from scratch. Now you're going to go in, you're in the organization. You understand fully what is happening in the organization. And the man them come and say, here the plan. We want to go do this, I want to go do that. And every time you have to start from scratch, you say, no, me have a formulation. And if you can do your formulation, I can go ahead now. And at any point in time, if I want to evaluate, say, if this is defined by my function, I want to evaluate f of 100. And I have this here. I know that I can just go and evaluate my stuff and get what it is that I'm supposed to get because I put my formulation in place. Whether or not you want to sell the company formulation, that's a different conversation, right? And that will become your intellectual property. So you can make the man know, so here the plan, you know, that I formulate something that you go to a board meeting and the man and say, what if we produce X, Y, Z and you just drop it to your formula and get it? And they say, oh, you have a formulation? Yeah. All right, let us have it. No. Let us talk some money. And this is how you make your money. Let us talk some money. Because I would have sat down and used my calculus to come up with a formulation. Let us talk some money and then can the big man talk about money and say your plan. And you get $500,000 and you just pass it over. And you get the man, you take the $500,000 and carry some money from your teacher, and then you just take the rest for yourself and then you're good to go. You're good to go, right? All right, I'm gonna take a quick break from there and just brush on something. I'm not even gonna show you what the graph looks like. I'm not even interested in a graph. Not even gonna give you that sort of stuff. I don't want to overwhelm you. Let me find another one. Yeah, let me look at this example. I'm not going to overwhelm you. This is just an icing on the cake. This is just some little red wine to wash down all that beef you just had. Now, they may ask you to sketch the graph of this function. They can ask you to sketch a graph of the function. This is vertical and horizontal asymptotes. All of what is right here, so it goes right up like that. I eventually, you know all of this already. I'm not going to go through that with you. You know all of that already. All of this right up here, you already know that. All right? Let me just jump to the example and prove to you that you know it. So they may ask you to, as I said before, SKETs, sketch the graph of f of x equals to that. My aim is not to word what the question is, it's just to understand what is happening. So what is new to you is vertical asymptote and horizontal asymptote. Those terminologies may be new to you, vertical and horizontal asymptote. What is not new to you is when it is that you're finding the point of discontinuity. You're finding the point of discontinuity, we normally set the denominator equals to 0. Talk truth.
Yes, sir.
Yeah, man. Anybody else remember other than those 3 persons who say yes? Hello?
You
Tony,
can't
can't drop us.
kind of break up, so never hear clear.
Oh, no, I'm sorry. I'm saying when you're finding the point of discontinuity, what do you do, Dexton? Remember, you put the denominator equals to 0 and solve, work out for x.
Oh, yes, sir.
Right.
DX.
No man, when you find the point of discontinuity, you're just going to set the denominator equals to 0 and work out the value of x. So this rational function, there is or are points that it cannot take. Why? Because you can't have a 0 existing in the denominator. You remember that story from Calculus 1?
Yes, sir.
Right. Tiana, remember that from this Cal?
Yes, sir.
Nice. Rashid, remember that from Calculus 1, 2 years ago?
No.
Cockroach. So
You get my message, by the way, sir?
Oh, sorry. I see a message in here. So
No, not
okay,
in
I
the
see
chat.
one.
WhatsApp.
Oh, no, I'm not checking it. My phone at charge.
Cool, cool.
All right. This one, I'll respond to you. Okay, thanks, Jermaine, for responding. Yeah, man. So for the point of discontinuity, you're going to set the denominator equals to 0. Anyway, I'm just running through this. I'm not really teaching it. I'm just running through just to put some icing on the cake. So I'll come back to this. So don't have to worry. So if you're not seeing it, it's not a problem. So I'm setting the denominator equals to 0, and I'm solving for the value or values of x. So in this case, I'm going to have 2x plus 1 all square equals 0. I'm taking the square root of both sides because I'm undressing. So because I'm undressing, I have to strip, but I can't just go inside this and strip. I have to take off this square first because this is protecting what is inside here. So I have to take the square root of both sides. When I do that, see here, the square root of both sides, of course, square root of 0 is 0. And when I take the square root of 2x plus 1 all squares, I only get 2x plus 1. So technically, I have removed this 2 here. Now I can subtract 1 from both sides. So I'm going to have 2x is equals to negative 1. See it right here, so. And then if 2x is equals to negative 1, I divide both sides by 2. So x is going to be equals to negative 1/2. So this here is what is going to be called my vertical asymptote. Then, sir, the same thing we do for the point of discontinuity. Yeah, at the exact something, but it have one different name now when it reach calculus 2. Right? One different name. When it reach there's something that I can't eat. And oh God, when I was much younger, one of my chores, and it's not that I grew up big, I recognize, the older boys would have gotten and these are cousins, would have gotten responsibility to cook the dog food. But of course, every night is me cooking the dog food. And we had a cashew tree and we used to trade cashew seeds. So them say, all right, if you cook the dog food, we give you 5 cashew seeds. And trust me, everybody wants to cook the dog food at night because at night when we cook the dog food, we'll roast the cashew seeds, right? And trust me, a lot of us used to just hoard a lot of cashew seeds. We count and we never have money them time never going back. So we just trade things in cashew seed. You can go shop for me, them send me a shop, but you can't go shop, you have to pay me how much cashew seeds you want. 10. So this is how we barter, all right? And so we used to cook cornmeal with the dog food and then any vegetable, anything at all, we just put in something from leftover meal for the day. So when I grew up and them start cook turned cornmeal, good turned cornmeal for people to eat, me can't eat it. To this very day, I get offended if I go to a restaurant and I say, oh, sir, do you want polenta? What you talk about? I don't call me that. I don't want it. Them say, no, man, it's nice, man. We use coconut milk in there and so forth. I don't care if you put
It's bad, sir.
Eh?
It's nice, bad.
You're nasty, Jesus. I can't eat it. No, seriously. I can't eat it. No, lie you.
Sir, but
sir.
lobster and them something there. You.
Me see my mother cook it one time and say, oh, she feel for turn cornmeal. I say, okay, good. Turn cornmeal and something else. I know there's something else me eat. Me nah eat it. Me nah eat it because when I do eat it, it just reminds me of when I was cooking dog food when I was much younger. Me can't eat it. And the same big spoon them use that, no dog food that. But anyhow, the point I'm making is in other part of, well, when I was growing up, we call it ton cornmeal, dog food. But the man on the hill call it polenta, right? And it is served with good meat, you know, swims and lobster and fish and calamari and them something there we can't buy on a regular basis, and oxtail, we can't buy them things on a regular basis, you know, because it is eaten into the rich people palate. What's the point? Here is something called point of discontinuity. We don't even want to talk about no big something about that. No, we're talking about vertical asymptote, right? We're doing the same concept we did in Calculus 1, business calculus, to find that point of discontinuity is the same concept we're doing here to find a vertical asymptote. All right? Look at what is happening here now. Look at the function here. So the function is this, right? To find the horizontal asymptote, I am going to not let x plus 1 be equals to 0. I need to change that. But I'm going to now find the limit of this function. G's on P, are you serious? Yeah, man. So let me just do this. I'm going to copy here. And I'm going to paste it right here. So for the horizontal asymptote, look at what I'm doing. I'm having the function, the original question that was given, see, Rockstone, is cut it, you know. Undo. Oh, copy. And paste. You have to be careful what it is that I do. Sometimes the fingers move faster than the brain. All right. So remember when we did this piece here, x plus 1, I'm going to expand my 2x plus 1 all squares. Remember, 2x plus 1 all squares is the same thing as 2x plus 1 times 2x plus 1. So when I expand 2x plus 1 times 2x plus 1, trust me, you can get 4x squared plus 4x plus 1. So I'm expanding the denominator here to remove the square. And remember, when you're finding the limit of a function as x tends to infinity, we're going to look for the highest power into the function and divide through it by it, talk through it.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, man. So what we're going to know is this x over x squared, this negative 1 over x squared, 4x squared over x squared, 4x over x squared, 1 over x squared. This is from calculus 1, from business calculus. That is same something we are doing. All right. And then now we're going to say this cancel in one of that leave just 1 over x. Hold on. Leave 1 over x. This can't go no further, so I'm going to write it back. See it right here, so 4x squared over x squared. We cancel out the x squared, so we just have 4 left. 4x over x squared, the x cancel out the 1 here, so I'm going to have 4 over x. See it right here, so. And the 1 over x can't go no further, so I'm going to have that. And guess what the statement is now? As this and this and this and this tends to 0, the function moves to 0 over 4. See it here, so 0 over 4, which tends to 0. So my horizontal asymptote is going to be equal to 0. My horizontal asymptote is going to be equal to 0. Trust me. So this piece is what we talk about, the vertical asymptote, is what we did for point of discontinuity. This piece here is when we're in limits and we're calculating the limit as x tends to infinity. So you see how we learn these things disjointly, meaning separate, but no, them come together to give you one final thing. And the last thing that I'm going to do in class tonight is to show you what the graph looks like. New share. Let me just, Lord have mercy. All right, I just want to show you what the graph looks like. Give me half a second, please. Let me just go to Desmos, DESMOS. Oh Lord, I shouldn't be doing this anymore. Okay, it came up. I can't surprise my computer like this because it does not do well with surprises at all. All right, so the function is x minus 1 over 2x plus 1 all squared. X minus 1 over 2x plus 1 squares. X minus 1 divided by 2x plus 1 all squares. All right. Now, look at how the graph look. Oh no, this graph is very out of order, doing things that we don't expect it to do. No, look at what is happening here. You remember I said to you that my horizontal, sorry, new share. My horizontal asymptote is at x equals 0. My horizontal asymptote, not x equals 0. Y equals 0. My horizontal asymptote is at y equals 0. Let me go back to this share now and show you what I'm talking about. See here, so it go, this red line does not touch. Remember when I read the graphs and I told you, I showed you some stuff before, it looks like it is touching the x-axis. It not touch it. It kissing it. It kissing it, but it not touch. It crosses here at 1. It crosses the axis, But when it crosses the axis, it goes very close to 0, to the x-axis, very close to the x-axis. But guess what? It not touch it. It really isn't touching it. It's the same thing on the other side. The other side didn't cross it, but guess what? It got close. It got close. It got close. I'm trying to bigify it. It got close to it. It got close to it. It got close to it. But if I tear it out, I mean, if I try to get it bigger, it's going to show you that, you see it? Can anybody see it? It don't touch it.
Yes,
right?
sir.
It gets very close. Let me go back to my default zoom. It gets very close. Now, what we just calculated, let me go back to it. What we just calculated here was a horizontal asymptote to show that this value here is going to be 0, meaning say the graph going to hover the x-axis. Watch this one up here. So the vertical asymptote, vertical means so, straight up, the vertical asymptote is going to be x equals to -1/2. Let me show you how the vertical asymptote come in play now. See just so? Let me just do something here. I need to find a half on the graph. Come a half. All right. So half here, 0.5. This is my vertical asymptote. It means say the graph here can't cross this. And the graph here can't cross this. And I'm going to give you a practical example of what this is. So this is my -1/2. Everybody see the -1/2 right here, so?
Yes, sir.
Yes, sir.
Watch it now. You see it tear out up here, so, and it wide up here, so. The piece are closer to the -1/2 than this piece. But this piece, no matter say it close, the piece are gonna move up to it, but it can't touch it. Watch it. This is my -1/2 line, The line here is -1/2. Come on, it's supposed to show me. Anyhow, this line here is my -1/2. So watch a line in the middle. Watch a line in the middle. You see how the piece here catch up the piece here and look like a piece here? It not touch it. It will get closer to it, but it not touch it. It can't cross it. Can't cross it. And I can go all the way down to, you name it, all the way down to that's 43, all the way down to 50, -57, -61. It gets very close to the -1/2. But I promise you, let me go to 100, -100 and stop right there. See that? And if I go all the way down to Timbuktu, it gets very close to this -1/2, but it does not cross it. So this is my vertical asymptote, right? So you may say, but sir, it's the first I'm hearing this term. What that mean next time? Talk to me, what that mean?
There's an energy drink named Power, sir.
So you're saying to me, no, my class is rough, so you need to go get some energizer? Well, possibly. All right, let me just go to that. All right. So that's what it is. That's all I need to show you. So you know what the vertical asymptote, you know how to calculate when the graph looks so, you know to calculate the graph looks so. Let me just give you a practical example of what the asymptotes look like. Unfortunately, there was an accident at the wharf today. I really hope that the guy didn't die. one of the big equipment collapsed, and I think somebody, based on what I saw, somebody was trapped on the inside. I won't die like that because it's not a place that I want to work. It's a very dangerous place, right? And I'm going to tell you how dangerous it is, especially if you are underground, when they're transporting the containers from the ship to the port. Very dangerous. So dangerous that you cannot get on plant without your reflector jacket, helmet, safety boots, etc., etc. Very dangerous. You see them guys who drive them something there, highly skilled. But do you know how those things are moved? They are moved with the assistance of magnets. They are powered. All right. So yes, they do have clips, you know. So when you look on top of a trailer, you know, you're gonna see several holes, and especially at the four corners, when this go down on it, it clips into that thing to hold it. But it is also magnetized. All right, magnetized, and this is like a magnet where these two poles are like poles, and they are going to repel each other. So them can get very close, you know, but there's going to be a space in between that. Guess what? It no matter how strong it is, nothing can happen between them, right? So everything that we do in mathematics can be related to something that we do in real life. When you go to some scrap yards in the States, how do you think they move the old cars from one place to the next? Magnet. You see something come up and just lick on top of the car, and the magnet come up and, you know, them turn it on, and when them reach where the car will go, them just turn off the magnet and the car drop, and them crush it and recycle it, so forth and so on. It's magnetized. And then something we're talking about, the whole concept of the graph getting very close to, but not touching. All right. I'm ending there. But these are some of the things that they may ask you to do to sketch a graph. Yes, I know I ran through this pretty quickly. I did this because this was easy for me to do now. Why easy, sir? Because we would have done this piece in Calculus 1. This is a point of discontinuity. You can't have a zero existing in the denominator. So you set the denominator equals to 0 and solve. That is going to be your vertical asymptote. When it is that you want to find your horizontal asymptote, you're going to find the limit as it extends to infinity. Sir, why are you finding the limit as extends to infinity? Let me show you. You notice this gone over positive infinity, and a piece of gone over to negative infinity. Yeah. So if I found negative infinity or positive infinity, I would have got the same answer. The piece of gone, no, 7, 8, 9, all of them reach Timbuktu. All of them reach on this. So this is infinity. That's where infinity is, right? So it means that all of this infinity is like that. If I had calculated it at negative infinity, I would have still gotten my answer to be 0. All right. I know tonight was rough. I thank you for turning up. You have to do what you need to do. You cannot allow one class to go without you understanding or catching up, or else dog yummy supper. Get a power drink, do what you need to do, guys, and have a good one. See you on Tuesday, God's willing. Say a drink for Jesus.
Sir.
Yes, honey.
Sir.
Yes.
Is it that your malice for when we not have class?
You sent messages in the thing? I don't see the message come up.
Sir, everybody else see the message but you.
Hold on. Calculus CAL. It's just one message. Oh, sorry. What is it?
It's just one message, don't it? One message where everybody sit down and wait for you for answer, sir.
Oh my Lord. I was okay, you know, because of that, I will sit down right here, so show that we use Newton Raphson to find the next 3 approximate and take them as a first. And I easy something like this, but I can't read for you and send out the answer.
The first part, I want the answer to, you know, the part where them say they must show whatever. because I know if to do the other parts of a
It
good
says
teacher.
show that the equation that has a root between 1 and 2.
Yeah.
You have to go ahead now and solve that equation. All right, let me do the first part and send to you then. Yeah, you're
Sir,
correct. I see your point.
the equation all right, sir. All right, sir.
You have to solve the equation in order to get that part. So I will solve the equation and show that the root is between 1 and 2, because I know you should be able to do the Newton-Raphson there. Sorry, I didn't. That one missed me. All right. Bless up, guys. I'll do that for you, and then I'm sending it off. Matter of fact, I won't even type it. My finger head kind of tired. Let me just write it on paper and then WhatsApp it.
Sir,
All right, guys.
remember
Yeah,
the message.
I'm gonna check your message, Rashim.
Cool.
Rash, do I have a number speak to the phone? Because you know. Okay, all right, no problem. We'll do, Rash.
Yes.
Come on, bless up, guys.
First part of the class, yeah.
Say it again. You want what about it?
No, may I say beg you the recordings as soon as possible, please.
Yes. I'm gonna get the corrections so we can sit up tonight from Susan. And then oh Lord, I have 1,000,001 messages coming in now. All right. Things will be sorted out. Peace and salutation, guys. I'm gonna go get some rest and then get up and do some work here.
All right, sir. Bless up.
Bless up.